Hi everyone, uh, welcome back. Today we are looking at reviewing what are equations and what are they good for. Okay, so an equation is a statement that two things are equal, such as 2 plus 2 equals 4. So you'll see that both sides of this equation equal 4. 2 plus 2 equals 4, and on this side of the equation is 4. Sometimes I explain the equal sign to be a bit like equal sign is a bit like a fence on a paddock. So if you imagine it's a big fence and there's a certain amount of animals on this side, and there could be a certain amount of animals on this side. And sometimes you need to move the animals from one paddock to the next, or one side of the fence to the next. Or it could even be, you could even look at it as though it was a gate. Sorry, I don't know what I'm pressing here. Alright. So essentially what's on this side, for it to be a true equation, because sometimes equations can't be true, there needs to be exact same amount on this side. So you can see on this side we've got 6, on this side we've also got 6. Okay, so here's some more equations. 7 times 5, 35, equals 30 plus 5. So you can see that that is a true equation because they are equal. 4 plus x equals 10 plus y. Well, look, we're not sure about this one because we don't really know what x and y are equal to. However, if we made y 1, that would be 11, and on this side, so to make this side also equal, or to make the equation a true equation, we would then need to find the difference, which I believe 7 would be, because we have 7, 8, 9, no, it would be 8, 9, 10, 11, no, it would be 7, sorry. So if x was 7, this side would be 11, and we would get a true equation. Okay, so let's start by solving the equation. So find a number that would make the equation 25 equals b times 10 minus b true. So what does that mean to make it true? Basically this side needs to equal this side for it to be true. So you've got 25 over here. What's something times 10 minus b would equal 25? Well, essentially it's determined by this part here. So if we had, for example, 10 or times b, I think for this one b might need to be 5. And then if we went 5, if 10 was, and b over here was 5, you would then get, I'm sorry, I'll draw it over here, 5 times 10 minus 5, which would give you 10 minus 5 would then be 5. You would then have 5 times 5, which is 25, and you would get 25 times 25. And that would make that equation true. However, if b were, for example, 6, then you would get 6 times 10 minus 6, which would be 4. We know that 6 times 4 is 166, 24, so that would be 24. So you'd end up with 24. Oh, sorry. 24 on one side and 25 on the other, and that would be unequal. So that would not be a true equation. So what do we need to know here in the blue? I'll let you pause this one to have a quick little read, but essentially an equation is a mathematical statement that two expressions are equal. False equations are equations where the left side does not equal to the right side, and we would use this symbol here, which essentially means does not equal to. An equation has a left-hand side, which can often be represented by the acronym LHS, or a right-hand side, which can be represented by the acronym RHS. A solution to an equation is a value that makes an equation true. The process of finding a solution is called solving. So those are things we need to know. Alright, so let's scroll down a bit and look at our first example here. So, is an equation true or false? We've got 3 questions here, A, B and C. So to find out whether these are false, you need to do the math. So 3 plus 8, 11. So we've got 11. Sorry, I'm using a new pen today. So we've got 11 on this side. So the right side also needs to equal 11. 15 minus 4 equals 11. This is a true equation. We'll look at them down here. 7 times 3, 7, 14, 21. Sorry. Okay, 21 on this side. Does the other side equal 21? No, that equals 25. That will not be a true equation. So for that one, you would probably use this symbol here instead of the equal sign. Now, x plus 20 equals 3 times x if x equals 10. Okay, well let's just go and, can I get rid of that? Let's draw in a 10 there. So imagine we've got 10 plus 20, well that would equal 30, equals 3 times 10, which would also be 30. Therefore we have a true equation. Alright, let's keep moving on to our next example. So we're looking up here at example 2. So starting a solution to an equation. So the question is state a solution to each of the following equations. In other words, solve for the unknown number. So 4 plus x equals 25. Well, a way to solve this one would be to, instead of, to minus 4 from each side. So if you minus 4 from each side, I'll do it up here. 4 plus x equals 25. Essentially, we would start by minusing 4 from each side. Oh, sorry. Minus 4. And if we did that from each side, we would be left with x equals 21. So our answer here would be 21. Next one. 5y equals 45. So 5 times y, sorry. If we go up here, so to solve this one, we've got 5 times y equals 45. We know that if we do the opposite to timesing and go minus or divided by 5 on this side and divided by 5 on that side, we would be left with, well, the 5 would cross out there, and over on this side we would go, well, what's 45 divided by 5? Your answer there would be 9. So we are left with y equals 9. There's a similar explanation just here. Okay, that's how you get the 9 there. Next one. 26 equals 3z plus 5. A few more steps in this one, which isn't quite said. The first thing you want to do here is go minus 5 off both sides. So if we go minus 5 over there, you're then left with 21 equals 3z. Okay, because those were cancelled out. Yep, so 21 equals 3z, 3 times z I should say, sorry. So 3 times z, similar with the last one, we want to go divided by 3. So if we divide by 3 on both sides, we are left with 7 equals z. So our answer there is z equals 7. The reason why we divided by it is because to get rid of the 3, or essentially move the 3 to this side or out of the equation, we divide it. We find the opposite of what the question is asking. So 3 times z, the opposite of that is divided by. Okay, next example is writing equations from a description. Essentially, this is using your written skill to write a verbal equation. So So the number k is doubled, then 3 is added, and the result is 52. The best approach for this one would just be to sort of write it as you read it. So the number k, so you write the k, whoops, is doubled. So doubled, so we know that there's 2 of them, so maybe we put a 2 out, there's 2 k's. And then 3 is added, 3, and then we've got 3, and the result, meaning equal, is 52. Akira works n hours, earning $12 per hour. So there's n amount of hours, and she is earning, well, if she's earning, that's times $12 an hour, and the total she earned was 156. You could also represent this as 12n, because we know that that means 12 times n equals 156. Alright, there you go. Brief review of equations. There's a few questions here. Go and have a crack of these ones here. Maybe try this one, this one, this one. And there's one down here that I'd like you to have a go. State a solution, and then have a go at writing an equation for a couple of these. Alright, there you go, first video into this topic. Have a go. Any questions, let me know. Alright, hope you enjoyed that. Thanks.